Hey everyone, today we will be performing operations on functions. So we let f and g be any two functions. The sum f plus g, difference f minus g, product f times g, and quotient f over g are functions whose domain are the set of all real numbers common to the domain of f and g and defined as follows. For the sum, it's f plus g of x is equal to f of x plus g of x. The difference is f minus g of x is equal to f of x minus g of x. The product is f times g of x is equal to f of x times g of x. And quotient is f over g of x is equal to f of x over g of x with g of x is not equal to 0. So basically, whenever we perform operation on functions, we just apply the usual addition, subtraction, multiplication, and division among those two functions. So let's have some example. Let's have here f of x is equal to 2x minus 3. And g of x is equal to 5x plus 1. So let's perform addition, subtraction, multiplication in these two functions. So let's have number 1. Let's have f plus g of x. So from our example, we say that f plus g of x is f of x plus g of x. So we take our f of x, which is 2x plus 3, 2x minus 3, I'm sorry, and add it to g of x, which is 5x plus 1. Let us put parentheses over the two functions f of x and g of x so that we can signify that we substituted from f of x to 2x minus 3. From here, since this is addition, the addition gets distributed to 5x and 1. So this becomes 2x minus 3. Then the addition gets distributed, so this becomes plus 5x plus 1. Then we add similar terms. So this becomes 2x plus 5x, that is 7x. Negative 3 plus 1, that is negative 2. Therefore, f plus g of x is 7x minus 2. Next, let's have subtraction. So for number 2, we have f minus g of x. And the way we define f minus g of x is f of x minus g of x. So again, we substitute the f of x and g of x with its respective values. So this is 2x minus 3 minus 5x plus 1. So we substituted here for 2x minus 3, it's addition right here, it's positive, so we keep it as 2x minus 3. But for this one, it's a negative, it's subtraction, so the negative value is distributed to 5x and 1, so this becomes minus 5x minus 1. Then we combine similar terms. 2x minus 5x, that is negative 3x. Negative 3 minus 1, that is negative 4. Therefore, f minus g of x is negative 3x minus 4. For the third one, let's perform multiplication. So for number 3, let's have f times g of x, and this is equal to f of x times g of x. So in this case, we substitute f of x as 2x minus 3, and substitute g of x as 5x plus 1, and then we just multiply the two binomials together, 2x minus 3 times 5x plus 1. So remember that whenever we multiply two binomials, we perform the FOIL method. So how do we go around that one? So let's start first with having the first terms, 2x times 5x, that is 10x squared. Remember, that's the first term. Next is the outer term, which is 2x times 1, which is positive 2x. That is the outer. For the next one, we have the inner, negative 3 times 5x. That's the inner, which is negative 15x. And lastly, we have the last terms, negative 3 times 1. That's the last, which is negative 3. So we have 10x squared plus 2x minus 15 minus 3. Then we combine the similar terms. We end up with 10x squared minus 13x minus 3. And this is our f times g of x. Next, let's have division of two functions. So let's use these examples. F of x is equal to x squared minus 4, and g of x is equal to x plus 2. So let's perform first f over g of x. Take note that we define it as f of x over g of x, with g of x is not equal to 0. So let us replace the values with our given here. So f of x is x squared minus 4 all over x plus 2. Now we can try to divide it by using either synthetic division, or we can just look for factors that we can divide so that it becomes 1. So let's look at x squared minus 4. If we remember from our algebra before, we can see that x squared minus 4 is the difference of two squares. So we can factor out x squared minus 4 as x minus 2 times x plus 2. If you don't remember this, please review the product of the sum and difference of two terms. Now the denominator is x plus 2. Take note that there is a common term, a common factor, which is x plus 2. So we divide them. In common notation, we cancel them, but what we actually do is we divide them so that their quotient is equal to 1. So we're left with x minus 2. Therefore, the f over g of x is x minus 2. For our last example, let's try out reversing both the f and g. So this time, let's have g over f of x. So this is well defined as g of x over f of x. So it reverses the order. So the order of how the functions are presented is very important so that we can define it properly like this. So let's try to perform the division here. So g of x is x plus 2 and f of x is x squared minus 4. Take note that we can factor out the x squared minus 4. So we now have x plus 2 all over the factors of x squared minus 4 is x minus 2 and x plus 2. So we divide the x minus 2's here. So we're left with 1 over x minus 2. Take note that there's a 1 here because the entire numerator has been divided, so we're only left with 1. So we have now 1 over x minus 2, and as such, g of x is 1 over x minus 2. Observe that it is a bit different from our previous example, which is f over g of x. So the order matters here whenever we perform operations, and the value of the function changes if the order changes as well. So that's everything for operations on functions. I hope you learned a lot today, and see you guys on the next video.